We have a quadratic equation with an unspecified linear coefficient, but we know that that linear coefficient is a real number. Okay, so we have a b here. Now, again, notice how trivial this problem would be if b were known. You would just do complete the square factor quadratic equation, but here b is unknown. Now, we're given that we have alpha and beta as real roots. We're also given the sum of the squares of the two roots. Alpha squared plus beta squared is equal to 26. And of course, we're supposed to find the roots, or sometimes called the zeros. Now, what we do here is we just go with our given information. Since alpha is a root, then x minus alpha is a factor. Since beta is a root, then x minus beta is a factor. When we expand that out, we get the well-known result. This is sometimes called Vietta's formula for the squared case. Okay. Now, by inspection here, we know the constant term is 12, so we can set alpha, beta, the product of the two roots, equal to 12. Okay, and then we just use some fairly routine algebra here, folks. Notice that alpha squared plus beta squared equals 26 becomes this with the substitution beta, and you can substitute either way. It's a symmetrical type of circumstance here, but beta can be certainly rewritten as 12 over alpha, right? 12 divided by alpha. Okay, and again, that's what we're doing right here is just using the fact that this is one equation, two unknowns, but this product of the zeros being 12 gives us this nice substitution, which is what happens going from here to here. I just replaced beta with 12 over alpha and squared it, and you get 144 over alpha squared. Now, if we multiply through by alpha squared, we get this equivalent statement. That's very easy to see. Now, we get a quadratic that you might think it's a hard one, but there's no cubic term, right? And so this is a nice complete the square circumstance here. A minus b quantity squared gives you the minus 26 alpha squared terms. Then 13 squared is 169. Okay, so we have to subtract off 169. Again, 13 squared just off to the side. 13 squared is equal to 169. Okay, and so we have to subtract off our mistake, if you want to put it that way. This would be minus 25 on this side, and then when you add it to both sides, you get this equivalent equation. And we're ready to just take plus and minus square roots. So this would lead to alpha squared. Now, I'll go ahead and we're going to take the plus and minus square roots of 25, which is plus or minus 5. So this would equal to 13 plus or minus 5, right? But what's that? What does that give us? That gives us what, 18 and 8, right, folks? 13 plus 5 is 18. 13 minus 5 is 8. And so what we get right here when you take the plus and minus square roots, folks, notice that 18 is 9 times 2. So we would get alpha equals to plus or minus 3 root 2. And let me just put comma here, 2 root 2. Right, ladies and gentlemen. So again, 18 is 9 times 2, so the square root of 9 is 3. 8 is 4 times 2, the square root of 4 is 2, and so you get this, and we have plus or minuses. Okay? Now notice what we have to do right here is the very same thing can happen with beta. See, we could have just as well made this substitution alpha is equal to 12 over beta, right? It's symmetrical in that sense. And so we can also write down that beta could take on these very same values. Beta could equal to plus or minus root 3 over root 3 times root 2. Let me squeeze that in there since I was talking rather than writing. And then plus or minus 2 root 2. Okay. So y'all, those are the possibilities for alpha and beta. And again, it's just because we arbitrarily chose to sub for beta right here, or express beta in terms of alpha, but we can express alpha in terms of beta also and get these, shall we call them, symmetric solutions. But these are the solutions, or the zeros, the possible zeros. It may seem like a little more than you would think, but it's what you would expect since we don't know what B is, right? B could be any real number. Now, so, you know, we would only have, if B were a known value, we would get just, I guess, 4 solutions, right? Or 4 plus and minus values. Here we're getting 8 plus and minus values because we don't know what B is. And also notice we never really had to know what B was, but if you must know right here, B would come out to be, it's going to be the sum of these values. It's going to be the sum of alpha and beta. So let me just write that in. We didn't ask for this, but we could also write down B is equal to, comparing right here, it would be minus plus or minus, gosh, this is going to be a mess to write down, but plus or minus, what do we got down here? 3 root 2 3 root 2, and then plus or minus 2 root 2. Kind of a mess there, but we didn't ask for that, but that would be the possibilities for the sum of the zeros, right? That would be those possibilities with a minus sign out front, and who cares? But anyway, we found the solutions here. This is the answer to the problem right here. Good night.